Okay, I gotta share screen now. Am I sharing screen?
No.
Okay. Now am I sharing screen?
Yes.
Slideshow. Where's that at? Slideshow. And then
The second one.
from
The,
slide.
yeah.
Perfect. Okay. So section 2, variables and types of data. So qualitative variables are variables that have distinct categories. Think of this as being like your major, or maybe whether you're male or female or non-binary or something. So these are ways to break up into categories according to some characteristic or attribute. So we have gender, color, religious preference, geographic location, maybe plant phylum or something if you were doing biology. Um, Quantitative variables are variables that can be counted or measured. So think of age, height, weight, body temperatures. Gemma is 3.5 and I am 36. So those are things that we can count or measure as far as age goes. Body temperatures are obviously very important right now because we're trying to figure out if you have a fever or not. Two types of quantitative variables. So we have discrete variables. Those are the ones that can be counted, right? So that's like number of flights that you've been on in your life is something that you can count. The number of students in this class could be counted. The number of calls received in a call center in a day would be something that could be counted. Continuous variables can assume an infinite number of values. And so those are things like, well, body temperature, because you can go to like 98.866 or something. Or what else could be something that's a continuous variable? Temperatures of a seashore resort, or yeah, systolic blood pressure readings. I don't remember if it's systolic. Is that the first one or the second one?
I have no idea.
I just know 120 over 80 is a good one. What is it? Systolic and diastolic or something? Yeah, well, we're not experts on that, I guess. Okay, so now we're going to talk about boundaries. So the boundary of a number is the class that, the boundary of a number is the class it would be placed in before it was rounded. For convenience, boundaries are written as lower boundary and upper boundaries. Usually we just say lower bound or upper bound, but are understood to mean all the values up to but not including the upper boundary. Boundaries are given in one additional decimal place and always end with the 5-digit. So 15 has boundary, that would be 14.5 to 15.5. Okay, so the lower bound is 14.5, the upper bound is 15.5, and notice that we're not including the upper boundary. So like 15.49999 is really the upper bound for 15, but that would be way too long to write, so we just write 15.5, right? And so we added just the 0.5 to the 15, added and subtracted 0.5 from the 15. Now for 1.6, we subtract 0.05 and get 1.55, and we go up to 1.65 for the boundary, right? And then finally 0.43, I'll let you guys think about what the boundary should be. Okay, pause the video if you haven't figured it out yet. That should be 0.425 to 0.435. Should I say anything else, Karen?
No, just that you can like kind of tell what the pattern is where you drop the last digit down by 1 and then add a 5 on it. And then basically just add a unit from there. And we will spend a lot more time with boundaries in chapter 2. So we'll get more practice there with them.
Awesome, thanks. Okay, variables can also be classified by how they are categorized, counted, or measured. This type of classification uses 4 common measurement scales. So we have nominal, the key word there is like name. So it's non-overlapping categories with no order or rank. So an example of that would be a sample of college professors classified according to their subjects taught, or students by their major. So history, mathematics, English, you really shouldn't rank those, although we all know that mathematics is way superior to the other ones. That's a joke, people. Okay, ordinal. Ordinal are categories that can be ranked. Precise differences between units of measure don't exist. So that would be like you're watching a whole bunch of presentations and you rank them as superior, average, or poor. So it's something that can be
Wait,
ordered.
can you hear me?
Yeah.
Okay, you were breaking up really bad.
Yeah, it says my internet connection is unstable. Hopefully the video is still good. We'll just keep going with it.
Okay, look, I think you should repeat what you said from the beginning there. because I couldn't understand most of it.
Really?
Yeah.
Okay, so variables can be classified by how they are categorized, counted, or measured. This type of classification uses 4 common measurement scales. So we have the nominal scale. That's where we have non-overlapping categories with no order or rank. You can think of this as like majors. You can't really say history is better than English or English is better than math, although I think we all know that mathematics is superior to all the other majors. It's a joke, people. Okay, so then another category is ordinal. So these are the categories are ranked. Precise differences between units of measure don't exist. And so this would be like you watch a presentation and the speakers are ranked as superior, average, or poor. You can't really measure the differences because some people might watch the same presentation and rank it as superior, whereas other ones would rank it as average. Interval ranks data with, and there's precise differences between the units of measure, but the big thing with intervals, there's no true zero. So things that have no true zero are things like IQ scores and temperature. So 0 degrees Fahrenheit is not an absolute zero. You can get colder than 0 degrees Fahrenheit, right? You go to negative temperatures and stuff. And so there's no like absolute zero there. I think in the Kelvin scale though, there is a zero, absolute zero. Is that right? The statisticians, the scientists in this classroom will either tell me if I'm right or wrong. Okay, another example would be IQ scores, because it's like the IQ scale goes from 700, goes to 70 to like 120 plus or something. And so I don't think that we know anybody that has a 0 IQ score. Okay, finally, the ratio is the same as interval, but there is a true zero. So things like that could be height, weight, area, and number of phone calls, because you can weigh 0 pounds or have 0 height, I guess. And you could start with, you could have no phone calls in a given day. So those are the sorts of things. The big thing is a ratio and interval. They're basically the same thing, but one has a true zero and the other one doesn't. Okay. And another example is like, it says one cat weighs 14 pounds, another cat weighs 7 pounds. So the ratio between them is 2 to 1. So that's the idea of a ratio, is because you have an absolute zero, you can rank them and say, okay, this is exactly it. The cat weighing 14 pounds weighs twice as much as the cat weighing 7 pounds. Anything else I should add, Karen?
Nope, that was good.
Cool. Okay, moving on to section 1.3, data collection and techniques. Okay, so there's different type of sampling methods, and this first 4 are typically the better sampling methods. So we have random sample, that's like one of the best you can do, and that's where all members of the population have an equal chance of being selected. This is trying to get rid of some bias, so you just select people randomly from the population to get your sample. So if I pick a student's name out of a hat to survey in this class, that would be a random sample of this class. And of course, I could sample multiple people doing this method. Systematic. So systematic is where you select like every kth person. There's some type of system for how you're picking them. So this could be like, I just go down the attendance list and I pick the 5th student and the 10th student and the 15th student and the 20th student, and I just sample them and ask them their opinions on something. Stratified sample is obtained by dividing the population into subgroups according to some characteristic relevant to the survey, then randomly select subjects from each subgroup. So this would be like, I divide the class groups into according to their current grade and pick some from each grade. So that would give me an idea of like how the people with a A, B, C, or D are feeling about the class. And then finally, a cluster sample is obtained by dividing the population into geographical sections or clusters, and then using all members in one or more of the clusters. So one example of this would be like, I pick all the students who live in Everglades Hall to survey. Another example might be like with the current COVID-19 crisis going on, we are breaking down a lot of our data into small clusters based on counties, states, even cities, and we're trying to monitor the populations in each one of those geographical regions. And so that's an example where a cluster sampling is a good idea. Okay, 2 examples of bad data collection would be convenient sample. That would be like where you just walk out your door and just sample the first 5 people that you see, or you call up your mom and dad and ask them their opinions on something because you know that they're going to respond. Or a volunteer sample. An example of a volunteer sample would be like, if you ever go to ratemyprofessor.com, you're going to see that there's either going to be people that love the professor or they hate the professor, but typically they feel very passionate about what they're saying about that professor. So it's typically biased. You don't get the people that are in the middle. It's either the people that just really, really like the professor because they're like the nicest person ever, or the people that think the professor is totally unfair because he didn't let them make up every assignment on the very last day of class, and it was just obviously just a bad person overall. Okay. Now there's different types of errors. A sampling error is when the difference between the results of obtained from the sample are different from the results obtained from the population. And so that is just like, you know, because you picked a subset of your population, it could be that you picked a few people that have a different opinion than the rest of the population. An example of this is November 8th, 2016. If you guys don't remember when that was, I think that's when Trump was elected president or inaugurated. Elected, right? Was that
Yeah.
election day 2016?
Yep.
So a lot of people thought that Hillary Clinton was going to win. I thought that Hillary Clinton was going to win. I like signed off of a Skype meeting at 8 p.m. and I was like, I'm going to go watch the first woman get elected ever in the history of the U.S. with my daughter. And then that did not happen. And so there's like, you know, the statisticians were polling people and they were polling samples of people and they thought that they could predict the outcome of the election, and they kind of missed. And so that was, you know, actually I know some reputable statistical sites like Nate Silver's site, he said leading it like the day or two before the election, he says it's too close to call. It's within a sampling error, so I can't say for sure. Okay, so a non-sampling error occurs when the data obtained is either obtained erroneously or is biased and non-representative. So that could be like you have a broken calculator or a broken measuring stick. Maybe your samples, like if you're doing a chemistry experiment, your sample was contaminated, or you survey the students from the wrong class, which I don't think I've ever done. I can't say for sure. Is there anything else I should say about this, Karen?
No, that was good.
Cool. Okay, section 1.4, the last section in chapter 1. So we have experimental design. In an observational study, the researcher observes what is happening or has happened and tries to draw conclusions based on these observations. In an experimental study, the researcher manipulates one of the variables and tries to determine how the manipulation influences other variables. Okay, so an example, let's try to do this real quick. Or should I give an example?
I would just do the ones that are there.
Okay, so example 2, determine whether the study is experimental or observational. A marketing firm does a survey to find out how many people use a product. Of the 100 people contacted, 15 said that they use the product. So all we did was call people and ask them, so that would be an observation, right? We're just saying, are you using the product or no? It turns out 15 are. Okay, a clinic gives a drug to a group of 10 patients and a placebo to another group of 10 patients to find out if the drug has an effect on the patient's illness. So this is going to be an example of an experimental observation or experimental study, because we're trying to control for whether or not you're given the drug by giving the placebo. So everyone thinks they're getting the drug, and then they can see if the drug has any influence on the person's health. All right?
Yeah, so I basically like just think of it as like observational. It's very hands off. You're just simply like gathering the data, whereas experimental, you're actually involved in it somehow. So you might be influencing it in some way.
Right. Cool. Okay, so the independent variable is the one that is being manipulated, or this is an experimental, right? The dependent variable is the other one, and then a confounding variable or lurking variable is one that influences the dependent or outcome variable, but was not separated from the independent variable. And so I just want to let you know that we're not really going to test you on confounding variables. We just want you to know that they exist. They're kind of hard to pin down. But here's an example of where these might show up. So it says, identify the independent and dependent variables. So it says the Journal of Behavioral Medicine reported that sharing a hug and holding hands can limit the physical effects of stress, such as soaring heart rate and elevated blood pressure. So the independent variables are the hug and hand holding, right? Those are the ones that are being manipulated. So you're either going to have a hug and a hand hold or you're not. And then they're going to monitor the heart rate and blood pressure. So those are the dependent variables. And then the confounding variables, well, there's many answers to this, but other things that can that can modify heart rate and blood pressure are medications, diet, exercise, age, mood, sleep, etc. Should I say anything else, Karen?
No.
Cool. All right, so we're going to go through this pretty quickly, but it's important. There are 3 types of lies: lies, damn lies, and statistics. Some people attribute that to Mark Twain, but I think it's actually an anonymous quote that predates him. Just because we read or hear the results of a research study or an opinion poll in the media, this does not mean that these results are reliable or that they can be applied to any and all situations. For example, sometimes reporters leave out critical details, such as the size of the sample used or how the research subjects were selected. Without this information, you cannot properly evaluate the research and properly interpret the conclusions of the study or survey. My Zoom window was in front of that word for a second. You should not infer that all research studies and surveys are suspect, but that there are many factors to consider when making decisions on the results of the research studies and surveys. Okay, so suspect samples. Here's a good quote you hear all the time. 3 out of 4 doctors surveyed recommend brand whatever, right? Or 3 or 4 dentists surveyed recommend Crest, Samples should be large and they should be random. 4 doctors is a very small sample. So that's too small. I also should thank Karen for making these awesome PowerPoints, by the way. This is her handwriting. Mine is much messier. Okay. Ambiguous averages. So mean, median, mode, and mid-range are all different types of averages, and they can vary significantly. So you need to be beware of the word average. So let me just give you an example of these different averages. If you have 3 people and one makes $10,000 and another one makes $30,000 and the 4th one makes $1 million, then one average, which would be the mean, would be, you would take $1 million plus 10,000 plus what I say, 30,000. So you'd have $1 million plus 40,000, and you divide by 3 and you would get like 300 some $1,000 as your average salary. Whereas if you take the mode or the median, what's the mode? The mode is the one that occurs the most common. So there, I think you average all 3 again. But then the median, you just take the middle one, which would be $40,000. So by taking the same 3 data points, you can either say that the average salary is $30,000, or you can say it's $300,000. And it just depends on which average you used. Is that right?
Mostly right, I think. I wasn't keeping track of your numbers as we went, but.
Nor was I.
Sounds good. And the point is just that average can mean, different numbers basically. So you just have to be weary of, when you hear the word average in a statistic, because you don't know which one they used.
Right. I have a better example. I might go back and redo this slide. Okay, and so another example, and moving on, we're changing the subject. So one way you could report a stat is you could say, during my administration, expenditures increased a mere 3%, versus a politician's opponent could say, during this person's administration, expenditures have increased a whopping $6 million. And so both might be 3% of expenditures, but the $6 million sounds a lot bigger than 3%. So it's just the way that the figures are reported. Both are correct, but which one, I don't know, better represents the data? I guess it depends on what your goals are. Okay, and finally, you should be very wary of detached statistics. So when no comparison is made at all, this is where marketing experts always use things like that. They say our brand of crackers has 1/3 fewer calories. 1/3 fewer calories than what? Than peanut butter, than chocolate, than other cracker brands? I mean, they're kind of like hoping that you think that's based on 1/3 fewer calories than Triscuits or something, but there's no reason to say that that's what they actually did. Let's see here, implied connections. Eating fish may reduce your cholesterol. So that word may is a really wishy-washy word. Other ones are like some and people say. These are all ways of saying, implying things that you can't really measure. Should I say anything else? I guess we're going to look at a lot of misleading figures here in the next chapter, so we'll just keep moving on. Okay, so misleading graphs. We're going to see a bunch of these in the next chapter. So misleading graphs misrepresent the data by altering X and Y scales. using exaggerated pictures. I was going to say like changing time scales or not keeping a uniform time scale, all different ways of making graphics that look, they suggest something that may or may not be true. And then finally, there's faulty survey questions. So if you're giving a survey, you could ask people, do you favor FGCU building a football stadium? That's going to have a different outcome than if you say, do you favor raising tuition so that FGCU can build a football stadium? Or at least that's going to have a different outcome if you're asking students, because I doubt students want to pay more money just to have a football stadium. But they would probably love to have a new stadium if it was free. Okay, so poorly written questions can influence the way they are answered. And that is the end of the chapter 1 lecture series. So thank you for your time. Karen and I will be back in a little bit with another chapter.